Repairing cheap household products such as these LED inverters economically usually doesn't make much sense. But it's a very interesting exercise, and in the following steps I'm going to look at a very common problem related to electrolytic capacitors. And now we've got the board open, and before we look at the obvious point of the problem, I want to just make a quick analysis. Here we have the primary side. Yeah, I know it should usually be turned around because you go left to right. Here we have the primary side. And here we have two electrolytic capacitors where you see a voltage of 400 volts maximum. And what happens here is that these guys usually store the rectified DC, which is then chopped up, and here it is smoothened out. And these capacitors, of course, they bear the brunt of the load. And as you see here, one of them has already farted out its electrolyte because of just overheating. It just cooks from the resistive losses. Whereas this guy is already starting to look bulbous as well. And incidentally, a tip from my old experience, these guys almost never fail. If you want to shotgun replace capacitors, stick to the secondary side and maybe the standby guys. But these large ones, which also are awfully expensive, normally don't croak. And yes, to take this apart, you just have to play with the case a little bit. You see, these are extruded form fits. These two screws are not for holding the case together. And yes, we can take out the PCB like so, and then we are already ready to play. And now, when it comes to actually selecting or repairing capacitors, it is very common to say, yeah, all electrolytic capacitors, they are the problem. But the reason for this is that there is an awful lot of very cheap aluminum electrolytic capacitors. And as you see here in the example of Worth, of course there are also other, you see, there are, for example, long life capacitors, there are general purpose, and what is also important is the temperature. Generally, the higher the voltage limit and the higher the nominal temperature, the more robust the capacitor will be. And in the position which we are in, I decided to go for these aluminum electrolytic capacitors, which are long life. And you see here that even at the maximum temperature, they get 5 to 10,000 hours. And of course, this increases exponentially as the temperature becomes lower. And now the interesting question is how to find the right part. And for this, I also like to use the Worth website, because you see here that you've got various different types of filter. And you can basically start out by filtering for the necessary capacity. And basically you start to scroll down here until you find the capacity which you want. And then you see here the original and the higher. And then you just check the correct dimensions. And we see, aha, the dimensions are a bit of a trouble. Because we see there is also a different family, the aluminum electrolytic low leakage, and we see the pitch is again correct, the diameter is correct, but this one is a little bit too high. So I decided to buy 10 of these, and also I decided to buy 10 of the other one, of these guys, as you see here. And then I just asked Worth to deliver them. And yes, here on the website, you can use this. For example, you can measure the diameter, and then you have the diameter of the part. And what is also important is the pitch. The pitch decides how far spaced the individual elements are. And yes, before you get soldering, you should think a little bit about what you do. These two ends are the ground ends, these are the plus ends. And so we basically already know the way which we are going to take. We have to desolder these 4 capacitors. And yes, I know that this is complete overkill, but because I spent so much time repairing the desoldering turbine in my old office in Bratislava, or rather updating it with a more modern power supply, I now want to play with it a little bit. And well, of course, in practice, you should do this with soldering wick, because it's just so much simpler. But if you have a turbine, why not do it? And yes, incidentally, if you use a turbine, you must always wait until it has reached the maximum level of heat, because otherwise you clog the piston. It is just stupid to not invest the 30 more seconds the turbine needs to heat up. And now we have the turbine, it has reached its target temperature. We check whether it sucks, which is important because these pistons can clog. This one has not clogged, and so now we start to desolder. And we see that the capacitor already wobbles around wildly. We can wobble it with the hand and it's ready to go. And now we go for its little buddy over there. This is a bit less willing to wobble. Now we go down here. We heat it up perfectly, and only when it's perfectly heated up, then while wobbling, we start the thing. The trick is heat it up first, and only when it's completely liquid all the way through, you push the button on the turbine gun. And now the turbine has already done its job, so we can proceed to the next step. Now we see these 2 capacitors are already wobbling around, so it's time to take them out and replace them. And yes, just before any moron makes a video out of this saying, electrolytic capacitors are bad. As we discussed before already, this is only a problem if you use bad quality electrolytic capacitors. And here I took 2 different high quality ones, both from Würth. And as we discussed before already, the problem is we have 2 different sizes. And now we need to find out which one of the sizes fits the extruded case. Because we really don't want to modify this case, because otherwise it gets dangerous. And what I now like to do to verify this is I take one of these capacitors out, and we see that they actually put in on the silk screen here some information. That's kind of nice. And again, of course, it goes back to Bunny's theory. And now I put this in like so, and then I just bend it down initially like this. And then I'm gonna cut these here. And then in the next step, I just do a dry run trying to put it together. And if it fits together, which you can basically feel by hand, this will fit together, then you know that the construction fits and you can solder in the capacitors. And yes, the basic soldering in, there is just not much to say. You see, I already pre-cut the leads, and now I'm doing something which you shouldn't do because I'm soldering over the head. I'm getting the solder gun here from the side. You shouldn't normally do this, but hey ho. And yes, you should use rather thick soldering wick, because when you work on through-hole, using the thin SMD wire is not only a waste of money, but it also makes your life ugly. And yes, never solder like this. And we do see that the solder they used before was very cheap, so we have some issues here with one of them not wetting properly. But for this, there is another trick which you can do. You can take a bit of this thing, hygrophobe colophonium, You put that here on these joints. And then with a really dry tip, you have to wipe the tip before in the sponge. You can go in and you can just top it up like so. And then you wipe it again. And then you just go through, wipe, wipe, solder, solder. And then essentially you've got your nice, well-connected solder joints. And at this point, depending on the material, some you have to clean, some you don't have to clean, and then you can already proceed to the reassembly, aka to putting the thing together again and getting it ready for installation again in the kitchen. And yes, this is really quite a cheap little device. It snaps together like so. You should do it from the top, of course, that makes it a bit easier. And then you just push it together and it's closed. And when you are dealing with a fleet like these, we've got 10 of them in the kitchen, you want to mark the repaired with an edding. So I take this here and I note down repair and a date, like 27th October, and I put down caps replaced. And yes, it's 2023. So now we have a note, so now we know what went wrong, which is incidentally why you always want to have an edding in the lab. And with that, I wanted to thank you for your attention. Once again, also big thanks to Würth for providing the capacitors used in the video, and I hope that this was interesting for you. Thank you.